So this is a pretty cool jig and fixture. So first we have the base, which will be taped down. You'll see that there's these 125 mil tooling pins. They had to be whittled down a little bit, but they're press fit into the design. This is going to hold the board. So then I take this, take my circuit board. Now there's no paste on any of these pads right now. Normally there would be if this was production, but I'm just showing for example. You'll see the top side of the board is already populated. So I'm going to just drop this down, and it should align very nicely and drop very easily into the tooling holes. Sorry for the light. So that aligns with the tooling holes, and these are 500 mil rails. These are in the centers of these corners. We only went with 2 because the 4 was just because of the tolerances. It was finding hard to press down, so we only really needed to align it with 2. Worked out great. Alright, now you're going to take the top portion. You'll see that the top part is flat. It was for manufacturing purposes. When we 3D printed this, we printed it facing up. We gave it all these little pegs on the bottom because they're going to rest nicely on the board. And essentially the honeycomb design was kind of a feeble attempt to mitigate some of the warping issues we would get when the 3D print would cool off. But you see we have the alignment, and we were able to get this design by exporting the DXF file from the Gerbers and essentially recreating the layout of the board. So you'd imagine there's paste on here. You'd have some parts populated in these areas after this comes off the surface mount line. So what you would do is very gently you put that on there, and then you would drop this on. Now again, what this is doing is I can press anywhere on here. It's not going to hit anything because we have those little studs sitting on the bottom. And you'll see that the tooling holes align and everything is really nice. Now over here, I'm just going to push this down for a second. You have a variety of different parts. So just as an example, I would probably have these lined up to orient the way that I'm going to be inserting them, because you'll see that the feet are offset from one another. And for instance, the left side here has more feet than the right side. So when I go to put this in, push this back in here, I would align it. I'll just do the middle one for right now. I would line this up. So this way doesn't actually line up. I have to turn it around. So it would be better to have these pre-oriented before I do all this part. This way I'm not fiddling around. But essentially, the old way of doing this was having to manually basically brace your arm, align this, gently drop it down to contact the pads, and then bump it around, hoping that you don't smudge too much solder paste. But then with this method, which was very, it did take a couple hours to design, and then we had to do like a redesign with the honeycomb pattern and kind of fix some of the tolerances. But basically we went through 2 designs, and it was pretty good. But you'll see here, all I got to do now is just align it and just drop it right in. And now that's perfectly aligned with the pins on the bottom, and you'll see some of these other parts. So this guy goes here, right? But see how easy that was? Just doing that alone, trying to line it up with the pads would take, oh gosh, that'd probably take at least 3 times as long, because you're being really delicate and gentle and you're trying to drop it down, and then it's completely contingent upon your ability to release the tweezers and not be shaky. This done. I don't even have to think about it. I don't have to worry about hitting any parts. I don't have to worry about tapping any of the inner surface mount or smudging any of the pads. And then finally, let's just throw a couple more on here for good measure. We'll do one of these small guys. Yeah, I got that oriented wrong. Again, orienting the feet beforehand would be preferred. You see it fits right there. Now, the beautiful part of this is I've got pull tabs here. I created 4 because initially I thought we were going to use all 4 of these pins, but then we did not. So then if I grab here gently and I lift straight up, it comes right off. Everything lines up. So now then these of course would be stuck to the pads. At the moment they are not, because there's no paste on there, but they align very nicely. And even if you did have to tap it a little bit, you've pretty much landed it right where it needs to go. And then you would gently lift this off. And if I pull up nice and close here, you can see these align very nicely. And again, there's no solder paste on the pads. So these will, if I go like that, they'll all fall over. But that wouldn't happen because, again, they'd be stuck to the pads with the solder paste. So you can imagine doing a panel of 3 like this times 333 panels, essentially 1,000 boards. Having to do 2, 4, 6 placements per board, 18 placements per panel, each one taking you 20 to 30 seconds of gently dropping them on, and you know, it's a lot of time. So this turned out to be a pretty cool design, and very, very cheap to make. Just overhead labor of trying to figure out the design. Beyond that, it's not direct. The cost of the material is just basic PETG. We used a Creality K1 Max printer, which was okay. It did have some, I wasn't super thrilled with the print in some areas. You can see even here, you know, the way this handled the finish on the bottom. It's just I like bamboo better. Anyway, cool.